Okay, let's solve this LeetCode data problem. The problem description is a little too long, so I'll be short. We're given some number of stores, and we have products. For example, in this test case, we have 2 products. We have 11 of product type 1 and 6 of product type 2. And we want to distribute all of the products among the 6 stores in such a way that each store can get only one product type. For example, store 1 can get 11 of product 1, but cannot get any other product type. Once a store is given some amount of some type of product, then it will not get any other products of different type. And after we distribute all these products, each store will have been given some number of products, and it says it could be possibly 0. So what we want to find is the minimum maximum number of products that can be given to any store. Now let me clarify what I mean. Okay, what do we mean by minimum maximum number of products that are given to any store? Now let's try to distribute these products among the 6 stores. Now I'm asking, is it possible that a store can get, let's say it's X, can get 12 products? Now it is not possible because we do not have any product of 12. So we have at most 11. So this means that any store can get at most 11 products. Okay, is it possible that the maximum number that given to a store is 11? It's possible. Let's say we have, okay, I'm going to draw this rectangles to represent stores. Let's say we have 6 stores, right? Okay, the first store gets 11 products, and now we give all of the products of first type, and now the second store can get 6 products. What is the maximum? It's 11. So 11 is possible. So now let's check 10. So basically this says, okay, if you can give any store at most 10 products, is it possible that you can distribute all of these products? We have 17 products, remember, in total. And is it possible that you will be able to distribute all of the products if you can give at most 10 products of one type to any store? Let's check that. So we're given 10, right? We can give this store a 10, then of first type, the product 1. Then we can give the next store a 1 from the remaining from the first type. And we can give this third store the 6 of all of the product type 2. So you can see the maximum is 10. So 10 is possible. It's possible that we can distribute 10. We can give any store a maximum number of 10 products in a way that we can distribute all of these products. Now let's, for example, check 7. Is it possible? Let me actually write it here. Is it possible that we can give any store at most 7 products and distribute all of the remaining products? So let's say we give this store 1 7 products of type 1. Now we have 4 products of type 1. Let's give it here, all of it. So since 4 is less than 7, it's possible to give this, right? We can give at most 7 products. Now we have 6 of product 2, so we can give it to here. So 7 is possible. We distributed all the products in a way that the maximum is 7. So 7 is possible. So should we check 8 here? So if you see, we check 10, and then we go back to check 7. So should we check 8? Well, it turns out that we don't have to. So if we can distribute all the products such that we can give at most 7 products to any store, then it is also possible that we can do it if we can give 8 products to any store. If we give 8 products, we'll give this one an 8, then 3 of the previously, when we give this one a 7, right? Then we give it, when this was 7, the second one get 4. When we give this 8, this will only decrease the number of remaining products distributed to the other stores. So it cannot make them more. So when we give 8, instead of 4, we'll give this one 3, and the remaining will get 6. So it is possible. So it is still possible. If we check for 9, we'll give this one 9, and we'll give this one 2, and this one will get 6. So it is possible for 8. Let's try even smaller values, like 5. So since whenever a value is possible, for 7, it is possible that we can do it. We will try smaller values, since we want to minimize the given maximum number of products to any store. So we have 5. We give this one a 5. So now we have 6 of the first type remaining. So from 6, we give 5 this one again. So yes, we could have give this one a 2, or we could have even give this one a 2. Let's just say that we give this one 2. So now we have 4 of the first type, right? Then we should give this one a 2. Then we would have 2 of this, and then we give this one a 2, and then you have 6. Then you can distribute it as 3 and 3. It's possible. This way is also possible. But if you, let's say if you give actually 1, then you would have 5 of first type, and you give this one a 2. Let's say you give this one a 5 again, and this one a 2, and this one a 2, and you can give this one a 6, right? Well, you distributed it, but you broke the rule, because we said that you can give at most 5 products to any store, but you give 6 now. So we have to, when we distribute that in among this stores, we have to give each store as possible the products should be maximum without exceeding the maximum number of a load product. If we're given 5, right? So we can give this one a 5, then we'd have 6, then give this one a 5, because we don't want to run out of stores before we can finish all the products, so distributing all the products. So we give this one a 5. It is possible, but we're not exceeding 5. So then there would remain 1 product of first type. Then we would give this one here, and then 6. We cannot give this one 6, but we can give 5. Okay, we can give 5 of second type, and then there remain 1 of the second type. We give this one, and this will get 0. So the maximum is 5. It's possible that we can distribute it in a way that every store gets at most 5. Any store get at most 5 product. Now let's even get smaller. Now for 5, it is possible, right? Let's check for 2, right? So we're allowed to give any store at most 2 products. Now let's try if we can do it. Now we give this one a 2. Now we give this one, so remember, we give every store as much as possible, as many products as possible, so that we don't run out of stores before we can finish giving all the products. So now we give this one a 2, right? So of first type. Now we have 7 of first type. Now we give this one a 2. Then we give this one a 2. Now we have, now how many? We have 3 of first type. Then we give this one a 2. And then we give this one a 1. So yes, we distributed all the products of type 1. Because we cannot give this one, this one's more than 2. We're allowed to only give any store at most 2. We distributed all the products of type 1. Now we have 6, but we don't have any stores. So it is not possible that we can do it for 2. So if it is not possible for 2, then we will not try smaller values. Because if we do this, we'll have, okay, if previously this was 2, now we try for 1. Then every store will get even less store. That with two maximum, we were not able to distribute all the products. when we're allowed to distribute only one product at most, then we will not even be able to possibly distribute all the products. So it is not possible for any value less than 2. So we try 3. So we try 3, we give this one a 3, we give this one a 3, we give this one a 3. Now we have distributed 9 of the first type. We have 2 remaining. Let's give this one a 2. And the remaining stores can get 3 of the second type. It is possible. So any store, the maximum is 3, and we didn't violate anything. So 3 is possible. So 3 is possible. So we want to minimize the maximum. So we would try 2 and 1, but since we know that 1 and 2 is not possible, the 3 is the only one that we want. That is the minimum maximum number of products that can be given to any store. For 4, is it possible? Yes, it is. If 3 is possible, then for 4 it's possible. For 5 it's possible. For 6, any value larger than 3 is possible. And 3 is the minimum one that we want. So you see, we have a space here. So when we try from 11, so there is a lower bound we go to. So any store will get at least one product, because you'll have at least one product here in the quantities array. So any store will get at most 1. It's not possible that we have 0. So the lower bound is 1. So you would try this process so down to 1. You wouldn't try for 0 or negative values. So negative values does not make sense even. So now we have 1. For at most we have 11, because we cannot give any store more than 11, because at most we have 11 in our quantities. So at most we have 11. So we found that for 3 is the minimum maximum that can be given to any store. So any value that is less than 3 is not possible. And any value that are greater than 3, it is possible. So you see there's a monotonic nature of this problem. So that is a telltale sign of binary search. We have a search space, and in this search space, some part of the search space is true and some part of the search space is false. Now remember the traditional way of binary search. You're given a sorted array in increasing or decreasing order, and let's say it's increasing order. You're looking for a value x. When you find an x here, let's say the value you want to find is here. All the values to its right is larger than this x, and all the values to its left is smaller than this x. So you wouldn't search x in this part, and you would also not search x in this part. So this is the x that you want. Okay, now let's try another example. Let's say we have 2 stores, and the products is 5 and 7. Now we can give at most 7. Okay, let's just give 7. So we have 2 stores, and to each store we can give at most 7 products. We give the first one 7 products, let's say the second type, and we give the second store 5 products of first type. Now it is possible we distributed all the products. Now let's try for 6. So we can give the first store the 6th product. Let's try for 6. Now we'll give this store 6 of this product. Now there would remain 1. And then we can give this one 5 of the second product. But now you see that we have 1 product left of first type. So it is not possible. When given 6, when we're allowed to give any store at most 6 product, the minimum number of stores that we need so that we can distribute all the store is 3. So we need at least 3 stores so we can distribute all the products if we can give 6 products at most to any store. So this is the way. So for 6, it is not possible. So the 7 was the answer. So that is the binary search idea here. We have a lower bound. Every store can get only one, at least one. It will get at least one product. This is a lower bound. And it will get at most whatever the maximum value in the quantities array. Right? For example, for the first test case, it was 1 and 11. And then we try a value in the middle. Let's say this value here. So this is mid, right? For this mid, we check if we can distribute all the products, if we can give any store at most mid number of products, right? If it is possible, then we would try to minimize this mid. We would say, okay, if this is possible for this mid value, it will be possible for any value larger than this mid. So we would try in the lower end of this one. So we would try here. We would try to find the value here. So basically, just in binary search, now we have a new bound. This one here, starting from the mid. So then we find a new mid here. And then for this mid, we would check, okay, is it possible to distribute all the products so that we, in a way that we're given at most, that we're allowed to distribute at most mid products to any store. How do we check if we can distribute all the products if we are given some number of products that we can distribute to any store? If says, okay, then we have a function x that would take this x, right? It says, okay, you're allowed to distribute at most x products to any store. So tell me if it is possible to distribute all the products in this case. This f of f function would tell you that. So how do we do that? So let's now build this check function. This is going to help us to check this condition. So in first case, in our first example, we have 11 and 6 of the first quantity, right? When given 4 as our x to input to our f function, now we need to find the minimum number of stores so that we can distribute all of this products. So for this reason, whenever we give products to store, we give as many products as possible, so that we can minimize the number of stores. For example, when you give the first store a store, you give 4, right? It is possible. 4 of this one. The second store, give 4 of this one, and then then remains 3 of the first type, then 4 of the second type, and now we have 2, so give 2 of the first type. So when we're allowed to give any store at most 4 products, the minimum number of the stores we need is 5. We cannot have less than 5 stores and distribute all the products, allowing for maximum product distribution. So it is 5 is the minimum. So we need this function. So for example, 11 can be distributed among 3 stores. So we find 11 over 4. So this is 2, right? And then we have a reminder of, so there's a remaining 3 product, and this will be distributed to any other store. This is a total of 3 store. So we find the ceiling. So you know this function, x over some value, let's say 3. This is going to find the smallest integer greater than x over 3 actually. So for example, for 11, it is 2 over some point. since it is 2 over something, it will find the smallest integer 3. So we would use this one. We say, okay, if we can distribute it 4 products to any store, what is the minimum number of stores we need so we can distribute all of these products of type 1? For 11, it is 3. We need at least 3 stores so we can distribute all of the products of type 1. We would do this for every store and add up all of the results. So then in total, this would tell us the minimum number of stores we can we need to distribute all of this product. For example, for 11 it was 3. For 6 it is going to be the ceiling of 6 over 4, which is going to be 2. This is here 2. This is 3 plus 2, 5 stores. So we have 5. So we need 5 stores. Then we would check, okay, 5 is less than 6. So one of the stores will get just 0 product. This is a load. So 5 is less than 6, so it is possible for such that we can distribute 4 products, at most 4 products to any store. So this is the check function. So now I'll show you the code. Okay, this is the general setup of the function. So we have the lower bound and the upper bound, so left and right of binary search. We said that at least it could be, the lower bound could be 1, and at most it will be the maximum value in the quantities array. This Q is the quantities array, by the way. And then we do a binary search. We find the mid, and I use this one always. Not always, maybe sometimes, but you can just use L plus R over 2. This avoids overflow most of the time. And then you have the function f. We check, okay, is it possible? Basically, this function tells us, so it's here. It tells us the minimum number of stores we need to distribute all the products if we're allowed to give any store at most mid number of products. So this tells us that. So if it is possible, then we would try to minimize this value. So that's why we're searching in the left side. So right becomes mid. Else it is not possible. Left, we're searching in the right side. So left, mid plus 1. At the end, we're just going to return the left. This will be the minimum value. And now let's look at the check function. The check function counts the number of stores we need. And there we have the ceiling. So I didn't use the ceiling function. This is a way to calculate the ceiling without using double floating point values. So we just add Q plus maximum minus 1. This is the divisor here. Divisor, and you subtract 1 and divide by max. This will give you the ceiling. And at the end, we check if this value, the minimum number of stores we need to distribute all the products, is less than or equal to the given, so the available number of stores, then it is possible. So then we return true. And according to this check function, we find the answer. So that is all for this problem. And actually, I'll now show you some similar problems that you can practice later. Here are some problems that use the same trend of binary search. In fact, I made a video on this cocoa eating bananas. So in most of these problems, you use some check function, just like we did in this one, and you have a lower bound and upper bound. You're searching in a range, and then you try to either minimize or maximize some value. So try to solve these problems on your own, and if you need explanation, you can drop a comment under this video. I'll try to cover this ones as well. And by the way, I mentioned the cocoa eating bananas. I have a video about this on my channel. If you want to watch, you can go and watch it. So that is all for this problem. See you in the next videos.